Factoring using the difference of squares. In this lesson we're going to demonstrate a very handy technique you can use to simplify polynomials, and it's called factoring using the difference of squares. Whenever you see a polynomial in this form, in this case x squared minus 9, where you have a variable squared minus a number, the difference of squares can be used to separate the expression into two factors. For instance, this binomial x squared minus 9 can be changed into the expression quantity x plus 3 times quantity x minus 3. In this lesson we'll show why this is a useful skill, explain why this works, and give some examples of how to do it. Here's a big reason factoring the difference of squares can be useful. This problem, a typical SAT problem, is one that can be done without using the difference of squares. But by using the difference of squares, this cleans up real nicely and helps a lot with time and avoiding possible mistakes. We'll solve this one later. The reason it works is because of what I'll now demonstrate. Let's take quantity x minus 5 times quantity x plus 5. We'll multiply these two factors together. We set up a box to multiply them using the box method. We'll place x plus 5 on the top of the box, and then at the side we'll place the other factor, x minus 5. In the upper left corner we have x squared. In the upper right we have 5x, and we put a plus sign there to make sure we keep it straight. In the lower left we have a negative 5x. And finally, in the lower right, we have the product of 5 and negative 5, which is negative 25. Next, we combine the like terms. And what are the like terms? They're here, the negative 5x and the positive 5x. And what are they combined? We have negative 5x plus 5x. They cancel each other and equal 0. And that's why the difference of squares works so neatly. There is no x term or linear term remaining after cancellation. So that's how we get to x squared minus 25 with no x term. And that's why it works. It produces two equal but opposite x or linear terms that cancel each other. Let's look at a few problems to apply the difference of squares. You'll probably get more out of this if you pause on each problem before it's worked out to see what you get as an answer before playing ahead to see how you did. Find the factors of x squared minus 100. Using the difference of squares, this factors out to quantity x plus 10 times quantity x minus 10. Let's look at this next one, 1 minus 4z squared. Using the difference of squares, this factors out to quantity 1 plus 2z times quantity 1 minus 2z. I hope you can see that it's 2z because 2 times 2 is 4 and z times z is z squared. Next we'll look at x to the 6th minus 36. And that simplifies to quantity x to the 3rd plus 6 times quantity x to the 3rd minus 6. Let's look at x to the 8th minus y to the 10th. This factors out to quantity x to the 4th plus y to the 5th times quantity x to the 4th minus y to the 5th. Let's look at one more, x to the 2n minus 1. This factors out to quantity x to the n plus 1 times quantity x to the n minus 1. I hope you're getting the hang of this. Let's take a look at that SAT problem we saw earlier. For any two different integers, a and b, let a asterisk b equal quantity a squared minus b squared divided by quantity a minus b. What is the value of a asterisk b when a equals 1 and b equals 2? And we have all the multiple choices shown below a through e. This a asterisk b is kind of a nasty twist. If you're like me, when I first saw this problem, you'll think a times b. But since a times b would be 1 times 2, and that's not one of the answer choices, that should be quickly ignored, but notice anyway the attempt to trip you up. Without further simplifying, we could substitute 1 for a and 2 for b and solve it. But it's a lot easier and faster using the difference of squares, plus safer as you avoid opportunities for errors. Since a squared minus b squared simplifies to quantity a plus b times quantity a minus b, we can rewrite it like this, quantity a plus b times quantity a minus b all over a minus b. Quantity a minus b in the numerator and the a minus b in the denominator cancel each other, so all we have left is a plus b, which equals 1 plus 2, which equals 3. So we go to our correct answer 3 and circle choice E. To be honest about it, we would have been able to get this one right without using the difference of squares, but look how easy it made it for us. Without the difference of squares, we have to put in everything, make sure we square numbers and subtract them properly, then divide by the difference in the denominator, which I think would be a negative number. Extra time and extra opportunities for mistakes. This might save you 30 seconds to a minute, plus possibly keep you from getting this one wrong. It might be worth 20 points on an SAT score just by allowing you more time on other problems. I've seen problems like this on PSATs which I've administered over the past several years. Now for you SAT and ACT takers, let me know, please, if you had the opportunity to use the difference of squares coming out of your test. I would really like to know. This has been factoring using the difference of squares. Thanks for viewing.